Profiling. Uh, Profiling is the process of looking at whether or not your code works, but whether or not it works fast enough or with a sufficiently small amount of resources to be able to run properly. And it's also things like checking whether or not at the scale that it's going to be run, it will actually work. Because although, you may write a wonderful thing for one person, when you have 1,000 people using it, 10,000 or 1,000,000, it's a completely different thing. So the most common sort of profiling is time-based. Usually if you're talking about profiling, most people start with does it run fast enough, which is really how long does it run using the CPU. And the simplest way to do this is to just use the time program built into the shell or the operating system that says just time and run this, and it tells you how long the wall clock time is that it ran. The problem with doing that is you're only running it once and you're counting all the initialization a single time. You're counting the amount of time it takes to load the program into memory, and that can be very deceptive for anything that's going to run for any large set of data, because that overhead time is counted a single time. So the way to get that overhead to not be a factor is to run the program a whole bunch of times and then divide by the number of times that you ran it. And I'm going to give you an example here. Usually you're using some sort of a profiling package that's built into the language or the IDE that you're using. There are these kind of profilings for every significant language that I know of. I mean, Go, Python. We're going to use a Python example. The particular Python example we're going to use is called cprofile, and you get to run it from the command line. So I have put together a simple chunk of code here that basically it goes out and implements grep in Python in a very simplified way. And I'm going to run it a bunch of times. I'll pass in on the command line the number of times that I actually run it, which is this loop down here that says for I and range times, so that we can actually run it 1,000 times and see how it works. And then the Python command I'm going to run is this one right here, which says load the module cpython and give me a total time. And then here's the parameters to my function that I want to test, this grep function. And it just goes out and looks in some files and opens the files and runs it and searches for a pattern. So it does something, and we're going to run it 1,000 times. Now I've got a sample of the output here, but let's actually run it. So here's the command to run it, and when we run it, this doesn't take a huge amount of time, but we get a whole bunch of output. Most of it at the bottom, since it's sorted by the amount of time it took, is not of interest to us. And when we get back up to the top, we'll see we've got a number of calls, a total time that it ran. Again, this is not huge, but this is the kind of output that you're looking at usually for a profiling output. What is important is it tells you how long it took to run specific things in your code, and those specific things are what you're after. Interestingly enough, it says that although I thought I was running it 1,000 times, it thinks that this thing on line 7 was actually run 2,000 times. That's also another interesting result that I didn't expect. But, you look through there and you go, oh, wow, this thing that I called 1,000 times results in something else being called 100 million times. How do I make the 100 million thing faster? Or how do I not call it? Or how do I improve the algorithm that thing uses because it's called so many times? Or why did it get called so many times? What was going on that I made the code work that way? Those are the kind of questions you're looking to answer. And legitimately, it's a table and it can be complex to look at, but you look through this and you're poking around, and it would be nice if you had some sort of a visualization of what's going on. And the most common visualization is a thing called a flame graph. And a flame graph basically tells you in your code you called these particular things the most number of times, or you use the most CPU doing these things over time. And flame graphs can be hugely useful in eliminating the things that don't matter and getting to the things that do in terms of what the performance is. So a flame graph is really nice. But lots of times, just the table with the profiling is sufficient. Now, this is not the only kind of profiling that you might need to do. You might need to profile for memory utilization or profile for network utilization, disk utilization, but there are tools for all of these different kinds of profiling to poke into them and look at a particular kind of thing in terms of the performance of your program. All right, next time we're going to do a review for the final, and it's been an exciting semester. Okay, 2020 is a year to remember. Let's put it that way.